Hello all. So today we're starting chapter 10. This is part 1, and this is body weight and composition for health and sport. Here we go. So weight control for our health is as important for our mental health as our physical health. There is a positive impact for regular physical activity in maintaining healthy weight. It can help improve mood, reduce anxiety and depression, and enhance overall mental well-being. Of course, the challenges are a negative body image, and so societal pressures can lead to stress, low self-esteem, and eating disorders. And then we go into body image. So a healthy body image is important. And so promoting realistic and healthy body standards helps individuals develop a positive self-image. Of course, the challenges are that media portrayal and societal expectations often lead to unrealistic body ideals, contributing to body dissatisfaction. Of course, weight control and our physical health, we've kind of talked about it throughout the whole term, but benefits are of maintaining a healthy weight. It helps to reduce the risk of chronic diseases, such as diabetes, heart disease, and certain cancers. It also improves mobility, joint health, and overall physical functioning. And the challenges are, of course, obesity and being underweight can lead to various health complications. As far as obesity is concerned, there are increased risk of cardiovascular diseases, type 2 diabetes, sleep apnea, and certain cancers. As far as prevention is concerned, a balanced diet, regular exercise, and behavioral changes are crucial for managing and preventing obesity. Anorexia is something, of course, that it is a health risk. It is considered to be severe weight loss, malnutrition, a weakened immune system, and potential heart issues. As far as treatment is concerned, medical intervention, psychological therapy, and nutritional counseling are essential for recovery. When we talk about weight control for performance, especially in weight-controlled sports, like wrestling, gymnastics, boxing, weight control is crucial for competing in specific weight categories. Some of the challenges with that are that athletes may resort to unhealthy practices such as extreme dieting, dehydration, and excessive exercise to meet weight requirements. In running, the runners often focus on maintaining an optimal weight to enhance endurance and speed. Proper nutrition and weight management are essential for peak performances. The challenges of that are, of course, balancing energy intake and expenditure to avoid fatigue and injuries is critical. If we look at muscle mass sports, the focus tends to be on sports like bodybuilding, weightlifting, and powerlifting that emphasize gaining muscle mass while minimizing fat. Challenges to that are ensuring adequate protein intake, managing calorie consumption, and avoiding anabolic steroid use are key concerns. Now, American football is definitely, you want to manage your weight depending upon what positions you're playing. So different positions may require different body compositions. Linemen may focus on increasing mass for strength, while wide receivers and running backs may prioritize speed and agility. So balancing muscle gain with cardiovascular fitness and managing weight to avoid obesity-related health issues post-career. And so weight control plays a significant role in both health and sports performance. For health, it impacts mental and physical well-being, while in sports it influences performance outcomes. Effective weight management involves a balanced approach to diet, exercise, and mental health support tailored to individual needs and goals. If we look at BMI, or body mass index, it's a simple and widely used method to estimate a healthy body weight based on an individual's height. If we look in metric units, it's body weight in kilograms divided by height in meters squared. In imperial units, it's body weight in pounds times 705. And then you divide that by height in inches squared. The normal BMI range is between 18 and 24.9 is considered to be normal, and it is associated with the lowest risk of weight-related health issues. In regards to the values for BMI, BMI is effective in identifying individuals who are underweight or obese, both of which can be associated with various health problems. As far as guidance for average individuals, for the general population, BMI provides a useful guideline for assessing whether body weight falls within a healthy range. The limitations to that are that BMI does not differentiate between muscle fat, and bone mass. As a result, it does not provide information on body composition. So for those who are muscular, like athletes or individuals with high muscle mass, they may be classified as overweight or obese due to their muscle weight, despite having low body fat. And then for some people with a normal BMI, they may still have a high percentage of body fat, which can be a risk factor for health problems. This is a classification of disease based on BMI and waist circumferences. And so if you look at it, you have the category on the left side, the BMI, and then what is their normal risk visceral fat deposition, and then high risk visceral fat deposition. And so BMI categories, underweight is considered a BMI below 18.5. For normal weight, it's between, again, 18.5 to 24.9. Overweight is 25 to 29.9. And then you have the obesity class, which is divided up into 3 different classes. So class 1 is a BMI of 30 to 34.9, and a BMI, or class 2 is BMI 35 to 39.9, and then severe obesity is anything greater than 40. If we look at waist circumferences, this would be for men specifically, it's greater than 40 inches or 102 centimeters. For women, it's a waist circumference of greater than 35 inches or 88 centimeters. Now, waist circumference is taken right at the smallest point above the hips, and so there's a little area there that you would take your measure, your tape measure, and it should be within those classifications. So as far as risk classification is concerned, again, normal weight, a BMI of 18.5 to 24.9. You have a normal waist circumference, that they would be at a low risk. For an increased waist circumference, they would be at an increased risk. And then overweight, they are, if they have a normal waist circumference, they're at increased risk. And if they have an increased waist circumference, then they are considered to be high risk. And obesity class, typically they would be, if they have a normal waist circumference, they would be at a high risk. For anything above that, it's very high. And class 2 and class 3 are considered to be very high risk to extremely high risk. If we look at body composition components, there are 4 major body components and their densities. So we calculate density by taking mass divided by volume. And so we put that in terms of grams per milliliter or grams per cubic centimeter. Now, total body fat, the density is considered to be 0.9 grams per milliliter. For fat-free mass, the density is equal to 1.1 gram per milliliter. And then bone mineral density is 1.3 to 1.4 grams per liter because it's just dense. And then body water, the density is about 1 gram per milliliter. So determination of body composition is usually done by calculating the total body density. So understanding body composition involves analyzing the different components that make up an individual's body weight. Part of that is total body fat. So it can be divided into essential fat and storage fat. Essential fat is the minimal amount of fat necessary for normal physiological functions. Males have approximately 3% of their total body weight as essential. Females, it's about 12 to 15% of their total body weight. As far as storage fat is concerned, that is fat that's accumulated in adipose tissue, and it serves as an energy reserve, providing insulation and protection to the body. And then we have subcutaneous fat that's stored just beneath the skin, and it includes cellulite. Visceral fat is stored around internal organs, which is more metabolically active and associated with higher health risks. Now, fat-free mass includes all body components except for fat. And they are crucial for bodily functions and physical performance. Protein and water. This includes muscles that are rich in protein and body water, which are essential for maintaining muscle mass and overall hydration. Now, our lean body mass, or LBM, is the total weight of the body minus the fat mass. It includes muscles, bones, organs, and water. Our lean body mass encompasses the essential fat required for normal physiological functions. So body composition analysis helps in distinguishing between fat mass and fat-free mass, offering a more comprehensive understanding of an individual's health and fitness. So total body fat, again, essential fat is about 3% for males, 12 to 15% for females. And then we have our storage fat, which contains our subcutaneous fat just below the skin, and then visceral fat around the organs. And then our fat-free mass, which includes protein and water, and lean body mass, which includes the essential fat. So if we continue on in our conversation about body composition, there are some additional details regarding bone, mineral, and body water components. Bones are essential components of the body's structure and play a critical role in our overall health. As far as their composition is concerned, they're about 50% water and 50% protein and minerals. The mineral content primarily includes calcium and phosphorus, which are essential for bone strength and density. Now, if in contribution to our body weight, total bone weight includes both protein and water content. Bones may constitute approximately 12 to 15% of an individual's total body weight. And water is the most abundant component in the human body. It is crucial for various physiological functions. So body water is distributed in different compartments. We have intracellular water, which is water that's contained within the cells, and it represents about 40% of total body weight. Intercellular or interstitial water is found in the spaces between the cells, and it typically accounts for about 15% of total body weight. Our extracellular water includes all fluids outside cells, such as blood, plasma, lymph, and interstitial fluid. The percentage of body weight represents about 5% of our total body weight. So a comprehensive understanding of body composition involves recognizing the roles and proportions of bone mineral and bone water. Again, bone mineral makes up about 50% water, 50% protein and minerals. And our total bone weight is about 12 to 15% of our body weight. Where body water compartments, the intracellular water is roughly about 40% of our body weight, and intercellular is 15% of our body weight, and then extracellular water about 5%. Water is a major component of the human body and varies based on factors such as sex and body composition. For an average weight male, they have approximately 60% of their body weight is water. For the average weight female, approximately 50% of their body weight is water. Fat-free mass and body fat have different water contents and play distinct roles in the body's composition and function. For muscle is about 70% water. Muscle tissue is crucial for movement, strength, and metabolism. As far as fat is concerned, fat tissue is about 10% water. And we know that fat serves as an energy reserve, provides insulation, and protects our vital organs. Body composition can be measured using various techniques, each with its own level of accuracy and application. These techniques can be broadly categorized into direct and indirect methods. The direct analysis of body fat is chemical extraction. This method involves chemically extracting fat from body tissues to measure its amount directly. It is highly accurate, but not really applicable to living humans. It's primarily used in research settings with cadaver studies. Now, all techniques currently used with living humans are indirect and subject to measurement error. The accuracy of these techniques varies, and they are often classified based on the number of components they analyze. The two-component models are divided. They typically take the body into fat mass and fat-free mass. As far as techniques are concerned, hydrostatic weighing or underwater weighing is one method, and another is skin fold measurements, using calipers to measure the thickness of skin folds at specific body sites, and bioelectrical impedance analysis, which estimates body composition by measuring resistance to a small electrical current. And we'll talk more about those in upcoming slides. And then you look at the 3 and 4 component models. These models divide the body into more components, such as fat, water, protein, and mineral, helping to reduce error. The techniques are dual energy X-ray absorptiometry, or DEXA. And then we have the air displacement plethysmography, or ADP. And then a multi-compartment models combine techniques such as DEXA, BIA, and hydrostatic weighing to provide a comprehensive analysis. Now, its accuracy varies. It's typically more accurate than two-component models. Hydrostatic weighing, or underwater weighing, or it's even called hydrodensitometry. It is based upon the Archimedes principle. So this technique looks at Archimedes' principle of buoyancy, which states that an object submerged in a fluid experiences an upward force equal to the weight of the fluid displaced by the object. This principle allows for the measurement of body density by comparing a person's weight in air with their weight while submerged in water. The procedure requires that the individual exhale completely and is submerged in water while being weighed. The difference in weights helps calculate the body density, which is then used to estimate body fat percentage. As far as accuracy is concerned, there's about a 2 to 3% body fat error. The advantages are that it is highly accurate and considered a gold standard for body composition analysis. There are some limitations, such as that it requires specialized equipment and can be uncomfortable for individuals. So it's not practical for large-scale or frequent assessments. So again, the individual's weighed on a standard scale to determine their body weight in air, and then they are submerged in a water tank and weighed again while fully immersed. It's done to measure the buoyant force that acts on the body. So you take the body density and calculate that, dividing it by their volume, the mass volume, and their density, and how much is displaced, how much water is displaced when the body is submerged. And that body fat percentage is estimated using that body density data and standard equations that relate body density to fat percentage. Again, it is considered to be the gold standard for body composition measurement. Air displacement plethysmography, or ADP, is a method for assessing body composition based on air displacement rather than water displacement. It's commonly represented by devices like the BodPod, such as what you see below. So the procedure requires that there's an initial weighing. The individual is first weighed outside the chamber using a standard scale. And then you measure inside the chamber. So they enter the plethysmography chamber, which measures the volume of air displaced by their body. This is done by comparing the pressure changes in the chamber with and without the person inside. And then body density is calculated from the volume and the weight of the body. Body fat percentage is then estimated using body density and established equations such as the Siri equation or Brazek equation. There are advantages over underwater weighing, and one of those is comfort. ADP is generally more comfortable than underwater weighing. It avoids the need for submersion and the associated discomfort or potential anxiety, making it more accessible to a wider range of individuals. And convenience. The procedure itself is quicker and less cumbersome. It typically requires only a few minutes compared to the longer process of underwater weighing. ADP reduces the risk of error that's associated with residual air in the lungs and other factors that can affect underwater weighing accuracy. So it's a reliable method for repeated measurements on the same subject over time, given that the measurement conditions are consistent. Body composition assessment, it's widely used in research and clinical settings for its ease and reliability in assessing body fat percentage and lean body mass. And it's useful monitoring body composition changes in response to diet, exercise, or medical treatments. There are some limitations in that it is costly and expensive and just less accessible than simpler methods like skin fold measurements or bioelectrical impedance. It also requires the specialized chamber that you see here, which may not be available in all settings. So overall, ADP is a modern and effective method for body composition analysis. It provides accurate, reliable measurements with greater comfort and convenience compared to traditional underwater weighing. And it has an accuracy level of about 2 to 3% body fat error. Now, if we look at skin fold measurement, it typically uses calipers to measure the thickness of skin folds at various body sites to estimate total body fat. Measurements are taken at specific sites, such as the triceps or the subscapular, and used in equations to estimate body fat percentage. The accuracy for that is about 3 to 4% body fat error, so just a little bit more than the bod pod. But it is relatively simple and inexpensive and can be done in a variety of settings. The limitations to that, it does require skilled technicians, so accuracy depends on proper technique and consistency in measurement. So you look at different sites and you're using the skin fold calipers. And again, there are population-specific formula. You have 3 components that you look at, or 3 sites that you look at, or 5 sites, or even 7 sites. So it is a good practical method, and it is typically one that's used by NCAA for wrestlers. With bioelectrical impedance analysis, or BIA, it is based on the principle of resistance to an electrical current that's applied to the body. The lower the resistance indicates greater water content and hence greater the body density or less body fat. Early research with BIA revealed large standard errors in predicting lean body mass. As far as the procedure is concerned, you place electrodes on the skin and the impedance or resistance to electrical flow is measured. There are also, you can stand on scales. Now, you know your bathroom scales. We have bathroom scales. There's also the InBody that uses BIA. The data is used to estimate fat mass and lean body mass. The accuracy is, it's about 3 to 5% body fat error. And the advantages are that it's non-invasive, it's quick, and often portable. The InBody is not as portable as some. Limitations are accuracy. It can be affected by hydration status, meal timing, and other factors. And more recent reports suggest improvement in accuracy compared to DEXA, except for individuals with very low or high BMI. And I've noticed with some, especially with Omron BMI, with Omron, the use of Omrons with BIA, for those that are younger than 10 years of age, it's not very accurate. So just one observation there. As far as dual energy X-ray absorptiometry, or DEXA, it is a sophisticated imaging technique used for assessing body composition. DEXA uses two different X-ray energy levels to differentiate between bone mineral, fat, and fat-free mass. The X-ray beam is attenuated differently by bone and soft tissues, allowing for the measurement of bone density and body composition. As far as the procedure is concerned, the subject lies on a table while the DEXA machine passes a low-dose X-ray beam over the body. Two energy levels are used to differentiate between bone and soft tissues. The machine's computer analyzes the X-ray attenuation data to collect bone mineral content, body fat, and fat-free mass. As far as bone mineral density, it provides accurate measures of bone mineral content, which is valuable for assessing bone health and diagnosing conditions like osteoporosis. It also measures total body fat as well as regional fat distribution, though it cannot specifically differentiate between subcutaneous and visceral fat. It also estimates lean body mass, including muscle and other non-fat tissues. The advantages are it provides highly accurate measurements of bone mineral density and body composition, and allows for the assessment of bone health along with body fat and lean mass in a single scan. It uses low-dose X-rays, making it relatively safe compared to other imaging techniques. The DEXA cannot specifically distinguish between the subcutaneous and visceral adipose tissue. Both types of fat contribute to the total body fat measurement, but their distribution cannot be directly observed. Subjects should be euhydrated, meaning they should be properly hydrated to ensure accurate body composition measurements, as changes in hydration status can affect the results. DEXA machines are relatively expensive and may not be available in all settings. And so it's frequently used in clinical settings to assess bone density and diagnose osteoporosis. It's also useful for monitoring changes in body composition, particularly in clinical research, sports science, and weight management. Overall, it's a valuable tool for assessing both bone and body composition. Its accuracy and ability to simultaneously measure bone mineral density, body fat, and fat-free mass make it a comprehensive choice for various health and research applications. And this chart, we've gone over some of this. There are some various methods that are employed to assess body composition, each with its advantages and limitation. And so I'm just going to cover some of the ones that we haven't gone over. Anthropometry, which is the measurement of body size and proportions, specifically ropometry. It is a term that might refer to the use of body segment girths to estimate body fat. This method involves measuring the circumference of various body segments, such as the waist, the hips, or the limbs, and using these measurements to estimate overall body fat percentage. Computed tomography is typically, or CT scan, it provides detailed images of body tissues to assess fat and muscle distribution. So it uses X-rays to create cross-sectional images of the body. It is highly accurate in measuring specific fat depots and muscle mass. So advantages are it provides precise measurements of fat distribution, but it is expensive and involves radiation, and as well as significant time. Dual photon absorptiometry, or DPA, is a beam of photons, usually from two different energy levels, that passes through the body, distinguishing between soft tissue and bone tissue. It primarily is used to predict body fat and calculate bone mass. It is effective in assessing bone density and body fat distribution. If we look at infrared interactants, The infrared light is passed through tissues, and the way the light interacts with tissue components is used to estimate body fat. It predicts body fat by analyzing the absorption and reflection of infrared light. Its applications are it's commonly used for quick and non-invasive body fat measurement. And then we have magnetic resonance imagery. And you probably have used this if you've had an injury, a bone injury of some sort. It's considered to be an MRI. It uses magnetic fields and radio frequency waves to create detailed images of body tissues. It's very similar to a CT scan. And it provides detailed imaging of body tissues, particularly useful for assessing deep abdominal fat. Its applications are it's valuable in research and clinical settings for detailed body fat distribution and muscle analysis. And then another is neutron activation analysis. So a beam of neutrons is directed at the body, and the resulting analysis of nitrogen and other minerals is used to estimate lean body mass. It estimates lean body mass by analyzing the body composition elements. It is primarily used in research settings for its accuracy in measuring body composition. So really just kind of detailing those techniques that we didn't cover previously. And continuing in that vein of for those techniques that we didn't cover previously, total body potassium measures the total amount of potassium in the body, which is primarily found in intracellular fluid. So potassium levels are correlated with lean body mass because potassium is an important intracellular ion. By measuring total body potassium, lean body mass and body fat can be estimated. It is useful in research settings for estimating body composition and monitoring changes in muscle mass. If we look at total body water, this is a little different than the underwater weighing. It's hydrometry. So it measures total body water using isotope dilution techniques, where isotopes like deuterium or tritium are used to estimate water content. Body water content is correlated with lean body mass since lean tissue contains a high proportion of water. This method helps estimate the lean body mass and body fat. It is effective for assessing hydration status and body composition in both research and clinical settings. And ultrasound. It utilizes high-frequency sound waves to create images of body tissues, allowing visualization of subcutaneous fat and other tissue layers. And again, it's used in estimating body fat by measuring the thickness of subcutaneous fat layers. It's often used for body fat assessment in clinical and research environments and provides a non-invasive way to monitor fat distribution and changes over time. So each of these methods provides unique insights into body composition and can be selected based on specific goals of the assessment and the level of detail required, as well as what type of resources that you have. So body mass index, or BMI, does not measure body composition, but it can be a useful screening tool to determine whether one is overweight or obesity, and really just to start that conversation with them. It's often used in doctors' offices for that reason. Overweight and obesity are not synonymous terms. It is possible to be overweight but not be obese, or at a normal weight with too much body fat. The body consists of 4 components. You have body fat, protein, minerals, and water. For practical purposes, body composition may be classified as consisting of 2 components, fat-free weight, which is about 70% water, and body fat. All techniques that are currently used to measure body composition, primarily body fat, are indirect and prone to error by 2 to 5%, depending on the method. And our present level of knowledge does not necessarily provide us with the ability to predict precisely what the optimal body composition should be for health or physical performance. However, BMI and body fat levels higher than normal are associated with increased health risks. And that is all that I have for you today. I look forward to talking with you again. Y'all have a great day.